In this inelastic collision, we're trying to first find the final velocity of the cars that are stuck together. And then we have a follow-up question. After the collision, they begin to slide, and they feel a kinetic friction coefficient of about 0.6. And we want to get the distance the wreckage slides before it comes to a stop. So let's look at the inelastic collision first. And I have P initial equals P final. And in this problem, we happen to have both cars moving towards each other. So I have two momenta to consider in the initial state. So I've got 550 times 10 for the rightward momentum of the smaller car, and then minus 800 times 4 meters per second for the larger car. And that's going to be equal to the total mass in the final state, which is 1350. It's all moving as one mass times V final. So it's just a matter of combining the terms on the left-hand side and dividing by 1350. And when I do that, I get V final equals 1.70 meters per second. All right, now I want to compute the distance that this wreckage slides before it comes to a stop. And I'm going to go ahead and draw a new diagram for this. So I've got my 1,350 kilogram combination of wreckage, and I'm going to go ahead and put some force vectors in here. I've got, of course, mg pulling straight down. And what I'm after here is the friction force. That's why I've got to do this. I've got normal force pointing straight up. There are no other forces tampering with the vertical direction, so the normal force is mg. And then the friction force is pointing the opposite of the sliding direction, and I'm going to call that Fk. That's going to be mu k times the normal force, which is mg. And then I have a sliding distance that I'll call x. So I'm going to opt to analyze this using energy instead of using forces, accelerations, and kinematics. And my motivation is really just to mix things up. I just wanted to try it in a different way. So the work energy theorem says the net work is going to give me the change in kinetic energy. Well, the only thing doing work here is the friction force. So the work done by friction is going to give me the change in kinetic energy, which is K final minus K initial. And I know that K final is going to be 0 because when this wreckage comes to rest, it's going to have a velocity of 0 and therefore a 0 kinetic energy. So let's look at the work done by friction. It's going to be negative for sure because the friction force points opposite to the displacement vector. Then I have the force of friction, mu k mg, and then the displacement, x, that's equal to negative 1/2 mv initial squared. My m's are going to cancel out. My minus signs cancel out. And I should be able to solve for x. X is going to be v initial squared divided by 2 mu k g. And now I can plug in the numbers, and I get 1.7 squared over 2 times 0.6 times 9.8. And I end up with a sliding distance of 0.25 meters or 25 centimeters.